We still need to speak about the chain rule to finding the derivatives for functions. We already talked about that in the previous video, and we discussed the case when we have function in the form f of x written not directly but written through another variable, like gx is function and f is a function of gx, like this way. Or in a different way, we can say y is function of, let me say, u, and u is function of x. We just discussed this case, and we said the derivative for y is y dash can be gotten by finding the derivative of f with respect to g multiplied by derivative of g with respect of x. This is the chain rule we discussed. Now, what if we have more than two variables? Here you see we have two variables, u and x. What if we have more than? Like the following case I will write. And u is function of another variable like v. U is function of v. We named it gv. And v also is function with x, like v is equal hx. See, we have here three variables. So how can we find the derivative of y with respect of x? It's easy, just the general using of the chain rule. We just find derivative of y with respect to u, then derivative of u with respect to v, and finally derivative of v with respect to x, and multiply all the result together. That means we can write dy by dx as multiplying over three derivatives together. The first one, the second one, and the third one. First one, dy by du. Second one, du by dv. And finally, or the last one, is dv by dx. See? One leads to another. One leads to another, and multiply all together. And we can do the same whatever the number of variables we have in any equation or in any problem. I will give you example on how to use this rule in this general case. If we have y is equal to sine for tan square root of sine x, find y dash, which means dy by dx. You see in this example, we have three variables actually, but they are not clear as written like this form. We have to get these three equations from this form. Then we start to apply the chain rule. How we will do that? We can start first by taking this as the v, which is equal to hx. So we can say this v. After then, go to the second one. We consider tan v. Here is v. Tan v is u is equal jv. And finally, we consider sine this is u. Sine u is this equation. So how to take each function will give you the key to go the right way to solve the question. Okay, let us see how can we will do this. As we said, we will start by consider v is, this is v, is the sine x under the square root. Function like this, we can find its derivative easy. We can say here dv b by dx is equal, here consider this as power, it will be power half. So it is like sine x to power half. So we take half and put it here. Sine x to power half minus 1 times derivative of sine, it is cosine x. Okay, after we got v, here we have v now. So this change into tan v. So we consider tan v as function like u. Say this is u now. U is the function tan v. And of course, you can find the derivatives very easy for this. We can say du by dv is equal sec square secant, I mean 6 square v. And you can make substitution about v from here. That's mean du by dv, it is 6 square, and put instead v, the value here, which is square root of sine x. Okay, then we move to the third function. What is the third function? Here we said all this now became u. So we have now y is equal sine u. Instead of this is u. So the third function will be y is equal sine u. Here's u. Okay? So the third function we said y is equal sine u. And also it is easy to find the derivative for this derivative of y in respect of u. This will be dy by du, which is the derivative of sine is cosine. So it is cosine u. And also we will do the same by replacing u by the value of it. We said u is all this between brackets. So we will put it again instead of u. Then we can write this is cosine, and instead of u we put what inside the brackets? Inside the brackets here, tan square root of sine x. So here tan square root of sine x. From the three steps we did, we multiply the result, this one by this one by this one. And this lead me to the final result, which is dy by dx. So we can write here dy by dx is dy by dx, which we can refer it by y dash, is equal dy by du times du by dv times dv by dx. By multiplying those, which is the same result here, we will find the final result. This equal, now put the value of this, which is here, cosine in brackets tan square root of sine x times, we put the value of this, which is du by dv here, sine square, sorry, 6 square, I mean 6 square, square root of sine x, then we put the value of dv by dx, which is here. This means this will be multiplied by 1/2 sine x to power minus half times cosine x. And we will try to simplify this answer to be a little bit easier. Here we can write it in different simple way by putting the power in positive. That means make a flip, put sine x in the bottom, and change the power from minus into positive. And this will be this only, we write it as fraction here, when here, and 2, and this will come in the bottom, will be sine x to power half, and this will be in the top cosine x. And again, this will be simplified also to be cosine x here 2, and this again is the square root, because the power half, it means square root of sine x. So this is this value, it's written here, and those two values also we write them cosine cosine tan square root of sine x times 6 square x. We can write it here, it will not make difference. So 6 square root of sine x. So we will write the answer, the final answer now. We'll write the final answer. dy by dx is equal here cosine in brackets tan square root of sine x times 6 square root of sine x times here the brackets line, sorry, the fraction line, 1 times cosine, that means cosine, over 2 square root of sine x. And this is the final answer. Okay? And if they ask you to find dy by dx at any value of angle, like pi over 3 or pi over 2 or whatever, you just make substitution about x by the value of the angle they ask you, like sine pi over 2, sine pi over 2, cosine pi over 2, sine pi over 2, and find those by calculator. Then we can find the value in numerical form. Okay, this is the notice and the example I wanted to explain for you before going to another topic in the next video. Thank you for watching. Hopefully I will see you again in the next video very soon. Bye bye.